So then how does one find this slope generating machine that gives us the instantaneous rate of change for any x value? Well, there is a shortcut, and it turns out that many mathematicians did the definition of the derivative. They did this long process until they got to their punchline, f prime of x, for a variety of functions, and they saw a pattern. Okay, so the first pattern that we're going to talk about that comes from applying the definition of the derivative is the power rule. Okay, so we have power rule derivatives. All right, so we've already talked about how you can rewrite some functions. And I'm going to start off with some easy power rule functions and then some that require a rewrite. So an easy one would be if we had f of x equals 9x to the 6th power. Okay, now according to the power rule, if you have f of x equals a x to the bth power, then the derivative, and notice this derivative comes from applying the definition of the derivative. Somebody did this a bunch of times and they saw a pattern. Here's the pattern. You can pull out your coefficient, and then the rule is that your power comes down to the front, just like the video is telling you. So you're going to multiply by your power. That's step one, is to multiply by your power. And then step two is to subtract 1 from your power. There's 2. Subtract 1. Okay? Let me close this off. So in this scenario here, your derivative, or your slope generating machine, means that you should pull the 9 out, multiply by the 6, that was the old power, and then you subtract 1 from that old power, right? It's that straightforward. Okay, so now we can simplify this. F prime of x then equals 9 times 6 is 54. 6 minus 1 is 5, and you're done. Right? So if somebody asks me, well, my function is 9x to the 6th power. I want to find the slope of the tangent line right at x equals 1. Well, that wouldn't be hard to do because we just do f prime of 1, which is 54, times 1 to the 5th power. Right? So this is 54 over 1, and this is m. All right, one section of stuff. This is the slope of your tangent line at x equals 1. Right? So if I wanted to find the slope of the tangent line at x equals 10, then I could just plug 10 into my derivative equation. Right? That's the beautiful thing about your slope generating machine. It will tell you the slope of your tangent line anywhere on your original function. So it's telling you what happens on your original function, the slope of the tangent line there. All right, another example. What happens if we had f of x equals 7x to the 100th power? Well, here's our derivative, f prime of x, then equals, pull the 7 out. This power is going to come down, so you multiply by 100, and then you'll subtract 1 from the power, so this will be 100 minus 1. And how does that simplify? Then f prime of x equals 7 times 100, gives me 700. 1 less than 100 is 99. And I'm dead. There's my instantaneous rate of change for this function f of x. And your derivative, again, is your slope generating machine. All right, so what would happen if I had something like this? F of x equals 12x. So then my derivative, I need to be real careful here because there's no power on the x, but there's only one x sitting there, so I can assume that this power is 1. So now I can go about my business with the derivatives, the 1 is going to come down and multiply by the 12, x to the 1 minus 1. So this equals 12 times 1 is 12, x to the 1 minus 1 is 0. Now this is an interesting piece of information because x to the 0 is 1. Anything to the 0 with the exception of 0 is equal to 1. So a rewrite of this would be that f prime of x equals 12 times 1, or just 12. Right, so what you'll notice is that when you have a number times just your variable, the derivative is just the number. So who knows, maybe that's a fluke. So let's try it again and see whether that would apply if we were to use another number in front of our variable. So what if now we had, let's do g of x this time. G of x equals 89x. Okay, so there's still only one x here, there. So then the derivative, our instantaneous rate of change, or our slope generating machine, is 89 times 1, x to the 1 minus 1, which gives you 89 times 1 is 89, x to the 0th power. So this is still 1. So then g prime of x equals 89 times 1, or just 89. So the same principle holds that if you have a number times your variable x, then it should just be the number. So then what would happen if we have a number by itself? Well, we have z of x equals 24. All right? So earlier I said that, well, let me first say that we can rewrite 24 as 24 times 1. Anything times 1 is itself. Okay, earlier I said that x to the 0 is the same thing as 1. So I'm going to rewrite this as 24 times x to the 0th power. So now I'm ready to take my derivative now that I have this last convenient rewrite. So then 0 multiplied by 24, or if you want to do it the long way, 24 times 0, x to the 0 minus 1. So then we're taking 24 times 0, which is just 0. And this becomes x to the negative 1. So if you rewrote that, your derivative or your slope generating machine, your instantaneous rate of change is 0 over x, which is just 0. Okay, so the point I'm trying to make here is if you have a number by itself, its derivative is 0. If you have a number with a variable, the derivative is the coefficient. Okay, again, number by itself, derivative is 0. Number with a variable, derivative is the number. All right, so let me do one where you have a string of items. So say we have f of x equals 3x to the 5th power minus 7x to the 4th power plus 9x cubed plus 10x plus 4. All right, according to the sum and difference rule, you should be able to take the derivative of each one of these individually, and the sum and difference should still hold. So I'm going to take the derivative of this first one, which is the 5 is going to multiply by 3, give me 15. I'm going to subtract 1 from the 5 and get a 4. Minus, notice this is holding, the 4 is going to multiply by the 7 and give me 28. I'm going to subtract 1 from the 4 and get 3. Plus, the 3 multiplies by the 9 and gives us 27. I'll subtract 1 and get a 2. Plus, okay, here's one of those rules you should memorize. A number times a variable will just give me the number. And then the last one is just a number by itself, which gives me 0. And I'm done. That's the entire process. Okay, again, these are the easy derivatives. Don't require any initial rewrites.